In this episode, I talked to Jaiyesh Chahar, a machine learning engineer who's experienced in statistical modeling, time series, deep learning, and end-to-end AI product development. He has been recognized as one of the top 5 AI community contributors in India by analytics Vidhya. He has published 4 research papers, holds 2 patents, and also serves as a community mentor in Python and data science. I came across Jayesh on LinkedIn as he regularly shares a lot of valuable content. And the product we're going to talk about today is called PetroForecast AI, an open source forecasting tool he developed with machine learning and language models. Hello, Jayesh. Welcome to the pod, man.
Hello, Alan. Thank you. Thank you for inviting me here.
What is PetroForecast AI?
So basically, it's a forecasting tool that is used to forecast the oil production. And also, a little bit twist there, I have also added a crunch of LLM on the top of this particular forecast.
No, sounds good. Yeah, I'm looking forward to see the magic. So feel free to just walk us through the interface and tell us how is it that it works.
So here, currently we are in the code base, and this is our GitHub repository. This is open. Anyone can view it. Who wants to see the code, who wants to run the code, it's open for all. Just run this main.py file. There are no separate modules there because again, it was at the POC stage. I haven't productionized it. So that's why all the things are present in this main.py. You just need to run this simple command, streamlit run main.py. Okay, and that will open this particular dashboard. So this will be the initial starting point of the dashboard. And now let's upload some data here.
Just to clarify for those viewers who may not be savvy with running Python or coding for that matter, obviously they need to know that an application like this one can be deployed and they can run it basically from a browser window. So they don't need to get into the weeds with code if they do not wish to do so.
Yeah, this can be deployed. I haven't deployed it, but people, if they want to deploy anyone, they can deploy it. It's again open source. Anyone can use it. It can be deployed on the Streamlit cloud itself, and it will be open to use for everyone. So now you can see I have uploaded a data file from Wallfield production. Again, Wallfield data is open source, and that particular initial data file is also present here. So I have cleaned the data and kept it here for you guys to see it, okay, or use it. So now, initially it's giving us some initial quick statistics. How many production days are present? What was the average production? Total how many days of data is present? Total how many total record was present? Then initial exploration or EDA step is also there where you can see the production versus date plot. Okay. And as it's a plot, you can minimize it. You can zoom in it. You can see how the production is varying. All those stuffs you can do. So now you can see data exploration. We have this particular plot, and also let's say some data scientist person or with a person with the petroleum engineer with a little bit knowledge of data science is present. So he or she or them can also see this particular feature correlation matrix. So they can decide which feature should be ideal for us to include in our include in our forecasting situation. So basically, they can select the features also from here. When we upload the data, it will take the columns and it will add into the feature just like that. So you can user can select the features also, what they want to use, which features they want to use for forecasting their model, forecasting their production. Okay. Currently, I have selected all of them. They can remove and select. And after that will come our model training and forecasting button. Just click on this button and your forecasting will start. Before that, I'll show you this particular left pane that is present.
So the idea being here is that you are presenting the user a correlation matrix so they can see just from the data loaded, what parameters are strongly correlated and what parameters are more weakly correlated. And then they have the ability to choose which of those parameters, based on those correlation strengths, are going to be used to move into the forecasting.
Yes, yes, Alan. That was the perfect explanation. Again, I was getting a little bit in the technical side. Sorry for that. But yeah, guys, and this is the basically scale here for the people who are not familiar with the correlation matrix. This is the scale here. So you can see the redder the value is, which means the high correlation is present. For example, this average downhole temperature and bore oil volume is quite dark, you can see. And this one is also quite dark, downhole pressure and temperature. So you can say that downhole temperature and downhole pressure are highly correlated with each other. What is correlation? It basically means if value of one parameter is increasing, others parameter value will also increase. So if average downhole pressure is increasing, average downhole pressure will also increase. If correlation matrix is positive, that's plus one. Highest value is plus one. And the lowest value is minus one. Minus one means if value of one parameter is increasing, the value of other parameter is going to decrease. Okay. So generally, when training a model, we only kept the parameters who are highly positively correlated or highly negatively correlated. The ones that are coming in this zone, in the zero zone, the white each one, we generally neglect those parameters. Okay. So
Makes
our
sense. Yep.
parameter of interest here is bore oil volume, basically the oil volume per day wise. So here you can see this total water injection and on stream hours are somehow not having any impact, that much impact on our model. So we can drop that if you want. Okay. And that thing we are talking about in terms of multivariate analysis. As I said initially, our application has two modes, univariate as well as multivariate. Univariate means it will only use your oil production history, basically only oil production parameter it will use. And using that parameter, it is going to forecast into the future. Multivariate use, it can use multiple features, all of them, to forecast into the future. Again, that thing is completely technical, how the LSTM works and all those stuff. I'm not going to get into that. Okay. And then there is this look back window days. So ideally, what this does, it does, let's say, let us give the example in terms of water injection. Let's say I injected 80 barrels of water today. There is a field present and there are two wells present there. Okay. One is your production well, other is your injection well. I injected 80 barrels of water today in the injection well. Now that 80 barrels of water, the impact of that 80 barrels of water on the production will take a little bit of time lag, right? Because water need to travel inside the reservoir and then it will start to push the oil towards the production well, right? So that time lag is present there. So our model need to understand that time lag, or you can say the time relationship of water injection and the oil production. That this 60 barrels of water will have impact on my oil production for how many days. So that thing you can understand is a look back window. So basically, how much days my model need to look back in the time to get to the current oil production. Basically, current oil production is impacted from how many previous days of data. That thing is this look back window. Okay. You can set it from 7 days to 100 days. Higher than 100 days doesn't make any sense. Let's keep it 16, 17 days for now because currently it's running on my local system. I don't have any GPUs right now. So if I train the model, it will take time. That's why I'm putting it on the lower side because higher the value of look back window, model need to look in past a lot. That will take high computation. So the training time will be required high. Then comes our forecast days. For how many days you want to forecast into future? Let's increase it a little bit. 72 days. Ideally, it's not possible. 72 days is a quite huge number. A lot of errors will accumulate. But yeah, for now we can put it. Then the training epochs. Again, a deep learning model is there. So epochs need to be defined. Again, epochs is a technical term related to the neural networks. It basically means how many times you want to show the data to your neural network model. Let's decrease it because again, high number of epochs will take time. Let's decrease it to 10 only. Okay. And it's loading. Again, it's a little bit slow on my PC because I am using a very old computer. If you have high computational power, it will be really fast. Basically, it's just throwing all the things in the back end that what a user has selected. That's why it's taking a little bit time. Okay, and after learning rate, the next thing will be your LSTM unit. These are basically number of hidden cells that you want to add in your hidden layers. 50 for now. Let's keep it default. Currently, we are using the univariate model, so they do not have any impact there. And after that, just click this train LSTM and generate forecast, and you can see this running sign here, which means my LSTM model has started to train. And if you open your backend, you will be able to see the logs in the backend that the training is starting. Let it start. This may take a few minutes. Let it run. Again, if you have high computation, good GPUs, it can do the work quickly.
While it calculates, let me ask you, there's no physics being incorporated into here. There's no Klein curve analysis or ARPS equations. There's no fractional flow equations. You did mention water injection into a producer. There's nothing like that here. No physics, no physical laws. This is just crunching numbers
Pure
in plain
database.
English. Isn't it?
Pure database, yes. And if we talk about the physics, generally the idea behind the neural network is this only, that it will try to understand the physics from the historical data only. And again, we can implement physics also if we just, in the neural networks, there is this loss function that is present. So in that loss function, if we add some partial differential equations related to the physical phenomena of any process, not only oil production, any process. Okay, let's say in oil production there is what you can say decline curve analysis is there. So if we create a PD of that particular decline curve analysis, and if we add that in the loss function of our model, then our model will start to learn the physics also. And by the way, that thing is known as PINs, physics enhanced, physics induced neural networks, PINs. A lot of research is going into that. It will have a major impact in a way that, let's say, if we don't have enough data, let's say we have only 500, 600 points of data points, right? But if we know the physics very clearly, that 600 points of data will also be enough to train any model to understand that particular physical phenomena.
So we, the users, have loaded a bunch of time series, and we have been informed of the correlation strength between all of those series. Then we have selected which are the ones we do want to use and neglect the other ones which are weakly correlated. And then the magic behind is, as opposed to us running, let's say, a decline curve analysis to produce a forecast, this thing is going to work out based on the relation between all of those parameters, what is likely to happen going forward, just by purely crunching numbers and by looking into the parameters we have selected based on the correlation strength we have observed in the time series loaded. Is that a fair explanation in plain English of what's happening here?
Yes, Ellen. Yes. That's the perfect
So we are
explanation.
interested in forecasting oil rate, but obviously we have more than just oil rate in what we've loaded. So this system actually works out, and this is what the machine learning model does, and the neural network is it creates a complex network of relations between all of these parameters, says the past, and then projects the future, just by purely looking into those time series.
Yes, that is the perfect explanation. And I'm seeing it taking a lot of time. Okay, I guess it has started here. So model has been trained. You can see RMS is 120 barrels per day, root mean squared error. However, mean absolute percentage error is quite high. It's saying it's not showing. Obviously, it will be high only using 10 epochs. And then learning rate is also there. Yeah, sorry guys, I forgot this learning rate. Again, a neural network thingy, you can change it from here. But yeah, by changing these all parameters, you can play around it and you can reduce further things. And a quick results and analysis is there. RMSE, it's showing MAE, mean absolute error, it's showing R square, again, a matrix to show how good our model is. Generally have values in between 0 to 1. Towards 1, it's better. But generally, it's also have negative values if it is very bad. And average forecast for these 72 days is 282 barrels per day. And here you can see this is our historical data from means last few days, and this is our forecasting data that it has forecasted for the future from September to November. So if you see here, we had the data till this August, right? And March till August. So after this particular data point, this thing has started. It's just showing that this forecast. And then it's also showing the result of the model of history matching. What was the, if you see the blue one was the actual production and the red one was the predicted production from our model on the blind data set, on the test set basically. Okay. So history matched, the model has history matched in a quite good way. At least it was able to capture the, you can see, capture the plot, capture the figure itself, curve, capture the curve, and then it forecasted into future. Then again, we have a quick.
Just to clarify there, Jayesh, sorry to interrupt you. Just to clarify there, on that chart you have there at the top right.
Yeah.
Right now there. So you have a section where the match looks pretty good, and then you have a section where the red curve runs below the blue curve.
Below the blue one.
So just to clarify there, where the match looks good, that is the training data set, and the other one is the off sample.
No. All of them are testing. All of them are testing. This thing is for testing only.
Okay. And
this is from the test split only.
Okay. And
training one is this. Training one is this. That's I'm showing below. Again, the complete history matching plot is coming. This is purely the test set. The idea here is why it's better here and why it's not better here is that if you see the data distribution was kind of similar in this particular thing. It was not varying or it was not having some spikes or something like that, right? And once once here at this particular point, maybe something has happened. We can see that oil production has reached zero, some shut-in has happened or some process has happened. And after that, there was a huge spike in the data and the range itself has changed. And our model is only trained on 10 epochs. Maybe the model was not able to understand completely what exactly this particular thing has happened here. That's why it's kind of performing lower than the actual value. Because at the end, it's just a statistical model. It doesn't have any information about the processes that are going on there. And it's a univariate model also. Let's say if we have put other features, there was a chance that it would have understand that, okay, my on-stream mass is 0, which means my model, which means my well is in shut-in mode. So let's increase it further.
Again, just to clarify, mate, just to remove a bit of confusion. So the fact that it's univariate, it means that you're predicting just the one, parameter, but you're still training the model based on all the chosen parameters. Is that
No,
right?
univariate means we are predicting one parameter and we have trained our model also on that particular parameter only.
So
So
just the one
basically,
time series has been used.
yes, none of them are used here. That will be used in multivariate if I select multivariate here.
Okay, so it's a single time
Univariate
series.
basically a thing will, let's say we have some sales data and from seeing the previous month's sales, I have to predict the next month's sale. So that is univariate.
Yeah. Okay.
At this particular point, the forecasting started, okay, on 25th August.
Yeah.
26th August 2015. So this 25th August 2015, the forecast of this will be done by the last, taking up the last 16 days of data.
Correct.
So
So that is
basically
a
it will be
moving window as you go to the right into your prediction. Yeah. Okay.
so basically it will take last 16 days of data as X and it will pass
Sure.
inside the function that is our neural network and the Y that we'll be getting will be the this
Correct.
25th August forecast.
Okay. Got it.
Okay. And this is that plot. And here again, a quick plot of your actual versus predicted values. On the y-axis is your predicted values, x-axis is your actual values. So if we get the value, these scatter points on this y is equal to x line, closer to y is equal to x lines, that will mean our model is good. If it is going farther away, means our model has started to behave badly. So that's why a quick, again, this plot is for statisticians, not for petroleum engineers. Statistician or mathematicians will be able to understand it more easily. And then
Yeah.
comes our complete history matching plot. Okay. Now this is the complete history matching plot. Now let me just show you quick things. Now this yellow, complete yellow thing. One more thing. This thing is our training data till this particular point. Okay. And after this particular point, this is our testing data that our model hasn't seen. Okay. And this
So that's the
dotted
out of
line,
sample. That's
yeah,
the
that's
out
the
of
out of
sample. Yep.
yes, that the blind set that model hasn't seen. And this
Yep.
particular red dashed line is the model prediction on the testing data. Basically, the
Yep.
model hasn't seen it and it has predicted it. Basically, this portion of the plot is this thing that we have already seen. Okay.
Yep.
And
Correct.
this blue thing, this is our history matched data. Basically, the production, the output from the model on the testing set also. So you can see there is a little bit down here also. Again, it can be improved if we increase some training posts or something. But more or less, it was able to capture the curve. Yes. So this is our complete history matching and forecasting plot. Not forecasting, complete history matching plot. Forecasting plot is this. Okay. So till this point, let's say till this point was my master's thesis. My research paper is also present. You guys can find out. I don't exactly have the link right now, but yeah, it's present. I will put it in my LinkedIn. Let me just search the link after that. But yeah, the main thing, the new area that comes here is this AI petroleum engineering cluster effect. So here, by using the LLM, we can get the analysis on the results and all those things. And there are different types of analysis, a comprehensive analysis that will be taking the production model and recommendations, operational optimization that can tell the immediate action and strategies that can be done, and risk assessment is there, production technical and economical risk.
So Jayesh,
What
just to separate things again for the user. So what we're going to look at now and what you're describing is a different type of functionality in which you are connecting to a language model with an API, which is, the magic that happens behind the scenes that allows you to talk to, let's say, a ChatGPT of sorts and ask questions. But up to here, and just to finish off your thesis work, let me just say that the interface looks very clean. The process, the sequence is quite clear, and it's for the user to basically play around with those parameters you have on the left pane and test out how the response changes with tweaking those parameters. The time axis that reads index, that is days, right? So you have
this one is
20,
days.
2,500 days.
Around 2,800
or
days.
yeah, 2,800 days there. And
Yes.
the lookback was only 16 days.
Yes.
So it's a tiny fraction compared to the length of the history.
Yes.
But as you say, there's no really a rule of thumb, and it's
Yes.
a matter of just trial and error, basically.
Experimentation.
Yeah.
Experimentation. Yeah. So you need to have an OpenAI API key. Basically, OpenAI LLM is being called
Yep.
here. So for using the OpenAI LLM, we require to pay them, and then they pay a API key to us. Okay. So API key, I have put it here. Mine API key. You guys should use yours, and after that you can select the analysis type. Let's go with the default one. Let's click on this get AI analysis. Let's quickly check. And it's working fine. And again, this slowness is not because of the application. It's again because of my computation thing. We have better computation, it will be fast.
Yeah.
So here is a compressive petroleum engineering analysis. Okay, so problem has occurred here. Maybe they have updated the OpenAI thingy. Yeah, actually, the code base is 2 months back. Let me see.
So while you do that, let me rephrase again in plain English for the users. What you're presenting here is the API is basically the way for you to talk to ChatGPT of sorts. And from within the application itself, you can actually ask ChatGPT questions about the data you have here.
Yes.
This is what's happening. So the prompt is what you send to ChatGPT with that API. And what is it that you're prompting in simple terms?
Yeah, I'll show you that. And also, let's before showing it because this thing is coming because of some version mismatch. Where maybe they have updated the libraries. But I'll show you. I have a video recording of this complete tool working. I'll show you that. And this
Yeah,
button is also to present there. That will again be calling the LLMs.
with
But
models.
now I again think it will be throwing up the same error. That's why, guys, always update the libraries on time. Always update your code base on time. I put it in idle for 2 months, and you can see the result here. And at the end, there is this download forecasting CSV file that will basically okay. This has worked, showing the performance level of the model excellent. RMSE is 7.6% of the average model. R square score is this. Recommendation, it's saying model ready for production forecasting. So that's a quick model assessment here. And then you can download the forecast CSV also. Basically, this forecasting values CSV file that will be downloaded. You can open it in your system. You can put it in some other software that you want.
So that model assessment, that score you got there, and those messages, rather than internally via the app analyzing the data and the results, you're actually passing all that to the language model and asking, what is the quality of this?
Yes, yes. And that thing is also done here, get AI analysis. I can let this code work, but again, that will take time for training the model. So let me show you the demo video. Okay.
How reliable have you found asking language model about these large data sets to be?
Uh, Again, depends how well we are. Means models are fine. Models are fine. The main idea here is that how we are going to make the process. Here currently only prompt engineering is there. But now let's say in future if we implement some further things, for example, let's also give a quick EDA report of our data to the model. Let's also give a quick forecast report of the data to our model, which means we are enhancing the process here, right? So if the process is good, the output from the LLMs will also be good.
Yeah.
So it's showing the complete thing here. In this thing we have already seen. Uh, and yeah, so this type
Yeah.
of thing will come in our Get AI analysis. Production forecast interpretation, it's showing the high annual decline rate of minus to 60% shows that reservoir is rapidly depleting. A more aggressive recovery strategy such as EOR techniques might be needed. Given the current trend, a hyperbolic decline model may be more suitable. Recalibrate the model to reflect this. With current declining trend, the EUR might less than expected. It's recommended to revise the EUR to 70 to 75% of the current.
Yeah.
Then model performance evaluation is also present. Reliability of forecast is also present. Confidence interval, all those things are present. And
Just to
hyper.
clarify again, mate, here, because this is obviously you're getting really, good and definitive insights off of your data set and your analysis. But what's happening behind the scenes is you're passing on to ChatGPT the whole data set, and then you're asking in plain English questions, and then you're getting replies in plain English, which you present in this response window. But you're using a language model as a data analytics, but this is nothing more than just talking to ChatGPT in plain English,
Yes,
right?
yes, yes,
Okay,
yes,
so people need to
yes,
be aware of that, and
yes,
obviously it comes with the caveat that sometimes it makes mistakes. This is not hardcore calculations behind. So it's just a nice way to streamline a few comments off of the data set that you're passing on to the language model.
yes.
Okay, good.
So again, as I said, if we let's say the calculation part, if we do ourselves and pass the statistics inside it, then it will be better or better result. But yeah, main idea was this hyperparameter optimization. So let's say I have passed my current hyperparameters of the model. I have passed the results. I have passed which model I am using, and if we also have some tools that can kind of control these particular values here to what the LLM can do, then it will not be an LLM, it will be an agent. Agent is basically an LLM with the
Right.
hands and legs. Hands and legs are tools that it can use. So LLM itself can control the hyperparameter values, train the model, check the output, see the results, calculate the error, then again train the with the different hyperparameters, again check all those things. So by doing that itself, LLM will be able to understand which features are important, which hyperparameters are important, how the hyperparameters are impacting my model's performance. And by default, it will train a best model for us. So instead of us
Yeah.
doing the work of hyperparameter tuning, the LLM will do the work for us, or the agent will do the work for us.
Yeah. And potentially, obviously, the user would have the ability to try out different language models. Doesn't need to be GPT with OpenAI. Could potentially be other
Gemini
language
or Cloud,
models
yes.
better um, suited for data analysis.
Yes, for example, for the coding part or data analysis part, we can use Claude. For some other thing, we can use GPT, just like that.
Yeah.
Okay, and in this way, this report is generated, and then this quick model assessment that we have already seen. And there are other things also, immediate step section and stuff. Let's see if that will come into the picture quickly. Optimization, engineering analysis. Yeah, so this is optimization result. So adjust stroke setting by 5% to control the pressure, 3 to 5% increase in daily production, increase in injection rate by 10% for next 7 days, maintain pressure. So in this type of operational optimization recommendation, it will also do to increase the oil recovery or to increase to maintain the pressure. Okay. So yes. And now coming to the prompt engineering part, let me show you the prompts. Okay. So for example, your production analysis. So here is the complete function for production analysis prompt. So you can see written your Dr. Sarah Chen, a senior petroleum engineer with this experience in North Sea operation. So here is the data, well identifier, current average production, maximum peak production, all those things are present here. Forecast result, model performance, hyperparameter used, and then provide a comprehensive petroleum engineering analysis covering the production forecast interpretation, model performance evaluation, hyperparameter optimization recommendation, data quality, all those things I have mentioned. Use petroleum engineering terminology and provide specific actionable insights, include numerical recommendations where applicable. So this was a prompt for the production analysis prompt. Similarly, there is the prompt for optimization prompt. This time we have said that generate specific operational recommendation for this particular well. Here are the model inside, provide JSON formatted recommendation in this well. For next
In all
7
those
days.
prompts, what you're passing is metrics and averages and distribution parameters rather than the bulk.
The data I said.
Yeah, the bulk input
Yes.
time series.
Yes, bulk input will be again costly. It can be fast, but again it will be costly and time thing will again be in picture. So yeah, generally, basically to give an idea, this type of prompts are generated basically so that our model gets the complete idea what exactly we want it to do.
Great, mate. I mean, what can I say? It's fantastic tool you've developed, and it's open source for anyone to have a play with this stuff. Yeah, just a brief comment to the users as well. If this feels a little bit overwhelming on the back end and coding side of things, a great use of ChatGPT or any other language model is to use them as how-tos and co-pilots. Just ask them, what do I do with this thing? How to set this up, etc., etc. So anybody really can get this running on their machines.
What you guys need to do to run the application.
I want to thank you, man. That was a fantastic tool you've developed. Good thesis work, and thank you for making it available to the community, man. For anyone interested, they can reach out to you on LinkedIn. And you've been putting together a fantastic series on petroleum from scratch YouTube channel. Yes. So I'm gonna link that in the show notes. And again, everyone can have a play with this and provide feedback to you and make this better for everyone, man.
Yep. Thank you so much, Alan, for inviting me on this particular stage. And it was great talking with you.